Our final topic for this chapter is the banked turn. It talks about how does an aircraft change its heading. A banked turn is a maneuver used to change the aircraft's heading. It's achieved by rolling the aircraft, which tilts the lift vector, which is the key to turning an aircraft in the air. This diagram shows it clearly. The total lift is directed at an angle. The vertical force component of the lift force balance the weight. So the lift force has two components, vertical components and the horizontal components. The horizontal components pull the aircraft around the turn. When the aircraft banks, the lift force, which is always perpendicular to the wings, is now tilted. This means we can break the lift vector into two components, a vector component and a horizontal component. The vertical component will exactly counter the aircraft weight, and the horizontal component provides centripetal force for the turn. We can analyze this with geometry. Let's assume this is the direction of lift force. This is vertical axis and this is theta. So apparently the vertical component, this is at the adjacent side of angle theta. So vertical component is lift force cosine theta, and it has to balance weight exactly equals to weight. So we have this vertical force balance equation. On the other hand, look at this is the vertical component of lift force. It should be calculated as lift force sine theta, because this one should equal to this side of this triangle. It's opposite side of this angle theta. Now, if this is the horizontal component of lift force, airplane is doing a motion like this, and this has to be a circle. Forgive me that draw it more like egg. Okay, and this horizontal component would always point into the center of the circle, which provides centripetal force. And then using Newton's second law, centripetal force equals mass times centripetal acceleration, and we know centripetal acceleration equals v squared over r, so we get the horizontal direction force equation. Lift force sine theta equals mv squared over r. An important consequence of this is that as the banking angle increases, the total lift required also increases to ensure the vertical component is still strong enough to support the aircraft weight. If a pilot banks too steeply without increasing power or angle of attack to generate more lift, the aircraft will lose altitude.